few more examples of solving quadratic equations by square rooting both sides and using completing the square. So, first thing I have to do is I try to see if this will factor into binomial squared. I see that it doesn't, that 3 doesn't quite work. The number I need I can figure out. 6 divided by 2 is 3, 3 squared is 9. I need a 9 there. So the best way to do this is to rewrite the problem. Minus 6x plus a space equals, move that 3 to the other side, negative 3 plus a space. I'm going to find the perfect number that will go there so I can factor this into a binomial squared. And when I find that number, I'm going to add the same number to both sides so that my equal sign stays equal, and I haven't really damaged the equality of the equation as long as I keep the balance the same. Add the same number to both sides. What's the number I need to add? Well, the process is take the middle term, what would be the middle term in the trinomial, divide it by 2, and square it. 6 divided by 2 is 3. 3 squared is 9. That's the perfect number. I have to add 9 to the other side. Now, when I do that, this side is easier to do, so we'll do that first. I get a 6. You agree with that? I figured this out so it would be a perfect binomial squared. 2 binomials exactly the same to multiply for that. Do you know what it's going to be? Well, x times x is x squared. Minus sign, so I need a minus sign. What goes here? Not a 9, a 3. All right, now that I did complete the square, I can finish solving by square rooting both sides. So I do square root of x minus 3 squared equals plus or minus the square root of 6. Remember, I have to use plus or minus whenever I solve by square rooting both sides because this unknown squared term could be a positive number or it could be a negative number because a negative number, when it's squared, is also positive. All right, so here's the fun part. Square root of something squared, x minus 3, equals plus or minus root 6. Finish solving, add 3 to both sides. X equals 3 plus or minus root 6. I can leave it like that. I could write 3 plus root 6 and 3 minus root 6 if you like to write it so that you have the 2 specific answers. Now, an important thing about complete the square, and all the ones I've done up to this point, the squared term always had the coefficient 1. This process of complete the square only works if the squared term has a coefficient of 1. Well, we got a big problem over here. That is not a coefficient of 1. What are we going to do? No problem. Let's divide everything by 7. As long as I divide both sides of the equal sign by 7. What's 0 divided by 7? That's easy, still 0. Okay, here's a tricky part. Each one of these has to be divided by 7. X squared part is easy. 7x squared over 7x squared. Minus 8 over 7x. Not a nice number, but we can deal with it. Plus 3 over 7. Now, I want to complete the square on this trinomial now. I know that that 3/7 is not going to work, so I'm going to rewrite the problem first. X squared minus 8/7 x plus a space for the number I'm going to find equals, that's going to be a minus 3/7 over here, plus the space for the number. I'm going to add the same number to both sides. Now, good thing we have a calculator, because we're going to need it. All right, remember how to find the middle term, the end term? You take the middle term, 8 over 7, divide it by 2, and square it. So, 8 over 7, negative 8 over 7 divided by 2. You can do this on your calculator if you want. I do it longhand. Negative 8 over 7 divided by 2 means multiplied by 1/2. And, oh, I see some nice reducing. So I get negative 4/7, and that's what I have to square. And when I square 4/7, I get 16 over 49. So that's the nice number that goes on that side. What do I add over here? 16 over 49. Now, at this point, I just factor what's left. This is going to factor to a binomial squared. I found the perfect number so it would work. What happens here? Factors for x squared are x. How do you know whether I have a minus or a plus? Minus. All right. What are the factors for the 16 over 49? That's why I left my work there. 4 over 7. Okay. What goes here? That's where the calculator is a little bit helpful. You can just plug it into your calculator. I do the old-fashioned way. 7 times 7 is 49, so 3 times 7 is negative 21 plus 16. I think that would be negative 5 over 49. You think? Negative 21 plus 16? Okay. Oh boy, negative there. We're going to have to bring in the imaginaries. So, next step here, I'm running out of room. I'll write a little bit small. So if I take the square root of both sides, I end up with x minus 4/7 equals plus or minus the square root of 5 over 49 I. Remember, I can take the negative out as an I, imaginary number. And then I'm going to break up the top and the bottom here. So let's write this again. X, do I have room there? I guess I don't have any room there. All right, so let's finish this up. Let me copy it up here so I have some more room. So I have x minus 4/7 equals plus or minus square root of 5. My marker's not doing so well here. Square root of 5 over 49 I. All right, so x minus 4 over 7 equals plus or minus, can't do square root of 5, but how about square root of 49? 7. And we have our I there. All right, can I finish solving this? Move the 4/7 over, or add 4/7 to each side. That's not so hard. X equals 4/7 plus or minus root 5I over 7. That is 2 answers. You could also write it like this. X equals 4 plus or minus root 5I all over 7. Some people like to write it I root 5 all over 7. Both ways are acceptable. Again, we got 2 answers. Be careful, use your calculator, check your work. Remember though, completing the square, you must have a coefficient of 1 on the squared term. This one was a big problem, that's 7. So remember I had to divide everything by 7.